Okay. First section is definitions of probability. I think you all are studied in A-level session or in A-level period also you studied what's the probability and those concepts are studied. But in this time also, these concepts are very important. Probability. You know, sometime you are going to select, you are going to choose something from uh, many many things. Then you can select, or you can, yeah, you can select some different thing. Now, then what's the probability? What's the meaning of probability? In here, I already mentioned what's the probability. Suppose that an event it can happen in H ways. Means uh, in probability, first thing is you need to define what is the event, and as well as you can define some event by using some letters. In here, I mentioned this event as a E. Okay, E can happen in H ways out of total of n possible equal like ways. Okay, it means what's the total events, what's the number of total events that can be happen as n possible times. Then uh, you are going to select, or your event happening times is h. Then we can denote this like as, then the probability of occurrence of the event call its success rate. We can call this one as a success rate is denoted by using this formula. Uh, P is the probability, probability or success rate we can call as in here. In here I mention what is the event. In here you need to mention what's the name of event. Uh, you can use any character. Uh, uh, in short form, we use E for events. Okay, event. Then what's the probability? You can define H divided by N, because what is the total number of possibilities? What the total number of possibilities is N. But uh, in here we explain some, we get some event as a E. That event can happen as H ways. Then you can mention probability as H divided by N. Okay, understood? If you cannot hear or any disturbance are available, you can mention. Okay, you can put any message through the message box. Okay. Uh, After complete 2 or 3 slides, I can give time to note those things. Okay. Okay. In here, I think you all can understand what is the probability, how to represent probability by using some total number of n's. And then after, what is the actually this is a occurrence rate, actual success rate. Okay. Then after you need to find, or you need to calculate what is the non-occurrence of the event. Uh, in here I mentioned the probability of non-occurrence of the event. You can call this one as a failure rate, or yeah, failure rate. In earlier one we mentioned as a success rate. Now you can mention this one as a failure rate, is denoted by Q. And then after, you can, as well as you can mention like this, what is the ways uh, that event can be failed? How to calculate? Uh, Total number of event is n. H mean I already mentioned that is the success ways. No, then you need to calculate failure. Um, how many times this event will be failed? You can get the answer. You can get the value by using n minus h. N minus h. Then you need to represent, or you need to present the probability of failure rate by using n minus h divided by n. No, I think you all understand this calculation. Then after you can simplify this formula, this expression like by. Okay. Uh, n divided by this n minus h divided by n. Then after n divided by n mean 1 minus h divided by n. H divided by n mean this p in here. Then after you can simplify these expressions 1 minus p. 1 minus p. P is success rate. I think you all understand how to calculate a failure rate. If you have any uh, trouble, you can mention in your message box. Okay. Okay. In here also mention some small expressions. Then now you can understand what is this expressions. P is the success rate. Q is the failure rate. Entire. If you can if we can get the summations of P and Q, final answer should be definitely it should be one, no? Because probability is a probability rate between 0 and 1. Then entire total rate is should be 1. Okay. If you need uh, to write down those things, you can write down. Okay. I can give 5 minutes. Yeah. You can write down those things. I think those things will be uh, very not will be very important to your final examination. Okay, this type of questions also available in your final exam paper. Okay, no? Okay, we can continue. Okay, this is the example for earlier we discussed the concept. In here, this is the first example. When die is tossed, you all know what is the die. Then die is tossed. There are six equally possible ways in which the die can fall. In I think you all play with this die. Then in this question mention the event E that the three or four turns up in the die. There are six phases. In particular phases available some dotted or some symbols like that. Then uh, in this question mention what's the possible rates for turns up three or four. In here mention we did not we saw what is the what we are going to select selected paces, three or four. Okay. In here, how to get the answer? This is a very simple question. Okay. The probability, the probability of E is you can uh, denote like this. Okay. Probability. What is the probability of event? Which event we are going to denote here? Then you need to mention that letter here. Okay. Probability of E equal how many possibilities are available? Three and four turns up. Only two no. Because when we considering die, then only two possibilities are available to turns up three or four. No? Only two possibilities. Two, this is the this is the three, this is a four. Then what are the total number of possibilities that can be turns up by consider when we consider in this guy? There are six possibilities are available. Then how to calculate our final answer? Our if we are considering only 3 and 4, then you can represent answer as 2 divided by 6 because total number of events or total number of ways can turns up this die is 6, but in these questions we are going to considering only 3 and 4 turns up. Then final answer is 2 divided by 6. Then otherwise you can simplify this answer as 1 divided by 3. Okay. In here also mention explain how to calculate or what are the non-occurrence rate uh, of this answer, as well as you can get those answers. Uh, I think this answer is very enough to your final answer. Okay, as well as you can write those things to get the more knowledge. In here, mention the probability of not getting a three or four mean what are the turns up when we are considering this die. Otherwise, you can get one. Otherwise, you can get two. Otherwise, you can get five and six. Those four events will be happen. Then, what's the non-occurrence rate? You can get the answer as uh, 4 divided by 6 mean 2 divided by 3 after simplify this answer. Okay, now all I understood or not. If you have some trouble or if you have uh, difficulties to understood this concept, you can mention. Okay, I can explain again and again. You all are okay with this concept? Okay, no? Okay, good. If you need this example also, you can write down, okay? This type of questions also will be available on your final exam paper. Not need to draw those face of die. Simply you can write down the question, okay? Okay, no? Okay. Next concept is conditional probability. Condition when we can discuss and consider conditional probability, we have to consider independent and dependent event. Okay, independence and dependent event. Uh, okay. In here we mention if E1 and E2 are two events. If E1 and E2 are two events, the probability that E2 occurs given that E1 has occurred is denoted by likewise. Uh, we already know E2. E2 already happened. Uh, E2 event is already occurred. Then, then after you we need to calculate what's the probability of E1 event that can be happen. Okay. Uh, this is a little bit complex concept. You need to clearly identify what is the concept of uh, in here happen. I all again mention if E1 and E2 are two events, the probability that E2 occurs given that E1 has occurred is denoted by likewise. Probability E1 already happened. If one if that E1 event is already happened, then what the probability of E2 event will be happen? Okay, then you need to calculate what the probability E2 will be happen. Okay, or likewise, you can represent. N is called the conditional probability of E2 given that E1 has occurred. Okay, E1 has occurred. Mean already E1 is occurred. Okay, if the occurrence or non-occurrence of E1 does not affect the probability of occurrence of E2, then you can represent the probability of E2 likewise. What the reason? This is a not dependent event. Then E2 event not depend with E2. That's why we can represent like that. Okay, understood. This concept little bit complex. Otherwise, you can understand. Okay, what's the probability of E2? What the reason we have already present like that. Reason is E1 and E2, those two events are independent. Okay, are independent event. Think there are two events, E1 and E2, but those two events are not depend with others. Then we can represent some events. I mean, E2. What's the probability of E2? Definitely, we can represent probability of E2 because that E2 event is not depends with E1. Okay, and we say that E1 and E2 are independent events. Otherwise, they are dependent events. If some those two events are independent, otherwise those events are dependent. No? That is a small concept. Uh, Main thing is in here, first you need to definitely identify how to represent this expression. Okay, those E1 and E2 events are not depend with others, then definitely you can represent what's the probability of some particular event likewise. Like, okay, understood. Understood or not? Yes, no? Okay. Only two or three persons are reply me, okay? Respond me, but those I think 70, yeah, 74 students are available here. How about others? Okay, no? Okay, okay, no? Good. Okay, good. In here, another concept is mean we can define by using this concept. If we denoted by E1, E2, the event that both E1 and E2 occurs, both E1 and E2 occurs, sometimes called compound events by using these expressions. what's the probability of E1 and E2 events are happen. Okay, E1 and E2 events are happen equal probability of E1 multiplied with probability of already E1 happen, already E1 happened. What's the probability of E2? In here, already mentioned what's the expressions of what's the expressions of here? Both E1 and E2 occurs, but we can express likewise. Okay, both E1 and E2 occurs here. Likewise, you can express. In particular, probability of E1, E2 being E1 and E2 occurs equal probability of E1 multiplied by with probability of E2. What the reason we express like this? Likewise. What the reason? Already, if if you understood earlier mentioned concept, then now you can identify what the reason for these expressions. What the reason for this expression? In here, we mention likewise what's the probability of E1 and E2 events are occurs. By using this expression, we can find the final value. In here also, another expressions are available. What's the reason? This is the E1 and when we consider in E1 and E2 events are independent, you can express this like this. Likewise, no? Yeah, good. Because those two events are independent. Okay. Yeah. Those two E1 and E2 events are independent. Then you can represent probability of E1 and E2 happening by using probability of E1 multiplied by with probability of E2. Okay. Yeah. Yeah. Good. All are good. Okay. Okay. Now, up to now, we are discuss only for this concept two events, but this concept we can apply for three events also. Okay. In here, I mentioned how to apply that concept for three events. You can simplify these expressions. Okay. This is the final answer. What the probability of uh, E1, E2, and E3 events are occurs, you can calculate by using probability of E1 multiplied by with probability of already E1 happened. Then after, what's the probability of E2 multiplied by with already E1 and E2 both events are happened. Then what's the probability of E3? Okay. Oh, then after here also mention what's the apply for that um, apply this expression for independent event when we consider in some independent event those uh, three events are independent, then uh, E1 will be happen or what is the probability of final probability values not depend with others, mean probability of E2, probability of E3. Then what's the probability of E1, E2, and E3 events are happen in same time, you can calculate by using probability of E1 multiplied by V, probability of E2, and probability of E3. In here also we mentioned what's the these expressions for independent event. Okay. Okay. Yeah, this concept also you can write down. I can give 5 minutes for write down those things. Okay. Okay, now. Okay, we can move another example. Okay, here mention let E1 and E2 be the event heads on fifth tosses and heads on sixth toss of a coin, respectively. The event E1 and E2 are independent events. This word is very important. Those E1 and E2 events are independent event. And thus, the probability of heads on both the fifth and sixth tosses is, what's the answer for uh, E1 and E2 events happening in same time? That's your answer. That's your question. Okay. Understood how to calculate this answer. Why we use these expressions? Those E1 and E2 events are independent. E1 event is not depend with E2. E2 event also not depend with E1. That's the reason. Okay. When we toss toss a coin, then heads can be come with two times, or mean head can mean total possibilities are two. Head can be one time, tail can be one time. Likewise. Then what's the probability of those E1 and E2 events happening same time, simultaneously? Simultaneously, you can multiply 1 divided by 2 and 1 divided by 2. What the reason? Sorry, E1 event occurred, probability of E1 is 1 divided by 2. Second event mean, yeah, second event happening time is 1 divided by 2. That's the reason we calculate this answer likewise. Okay. Here also available two examples. Uh, you can write down those questions and you can calculate final answer for those two questions also. Otherwise, as well as you have to face two exercises after finish this chapter. Before that, you can complete those two questions. Okay, those questions are very small and very simple. Okay. Okay, no? Example 4, so you can understand very easily. If the probability that A will be alive in 20 years is 0.7, and the probability that B will be alive in 20 years is 0.5, then the probability that they will both be alive in 20 years, what's the answer? 0.7 multiplied by with 0.5. What the reason? Anyone not depend with particular events. Reason A event not depend with B event. That the reason we get answer likewise. Okay. Example 5 also very easy. Yeah, they are independent, mean not depend with others. Yeah, good. Example 5. Suppose that a box contains three white balls and two black balls. Let E1 is event, first event, be the event, first ball drawn is black. Uh, you can suppose some big box will be available, though that box contain three white balls and two black balls. After that, we are going to consider in two events. For if event one is first ball drawn is black. Second event, E2, we can mention as E2. Second ball drawn is black. Both uh, first attempt and second attempt, two balls are black. Okay. In here mentioned where the balls are not replaced after being drawn. Mean after getting the first ball, uh, then after we are not going to replace when we get the second ball. Okay. Here E1 and E2 are depend event. Okay. Then that the first ball drawn is black. How to calculate probability of E1? Uh, what the how many ways that event can be happen? Two times, no? Because reason is in this box available two black balls. Divide by total number of ways. What the total number of ways? 3 plus 2 mean three white balls and two black balls are available in this box. No. Then what's the probability of uh, event 1 is 2 divided by 5. Okay. That one is very easy. Then after the probability that the second ball drawn is black, given that the first ball drawn was black, is uh, I think now you need to apply earlier studied concept. E1 already happened. E1 event already happened. Then what you need to calculate what the probability of E2 event happened. Okay. Then you need to you can calculate that one likewise. 1 divided by 3 plus 1. 3 plus 1. Why here we mention 1? In this question, clearly mention first ball, we are not going to replace again. That's the reason. Okay. That's the reason. In here, you can read down likewise. E1 already happened. E1 event already happened. E1 mean 2 divided by 5. Then E2 event, what's the you need to calculate what the probability of E2 event is happen. Okay. In common sense, you can calculate this answer likewise. One, what the reason of one? Only one balls are remaining up to now, no? Because already one black ball is drawn, already drawn. No, then only one black balls are remaining. Then after what's the total number of balls are available in this box? Only four. three white and one black. Then you can calculate the final answer 1 divided by 4. Likewise, okay. In here mentioned, thus the probability that both balls drawn are black keys. Likewise, you can calculate final answer likewise. What's the probability of E1 and E2 mean E1 and E2 happens mean first attempt and second attempts or in happening simultaneously. You can calculate likewise. Okay. Probability of E1 multiplied by with probability of E2 given E2 E1 has occurred when E1 event already occurred. Both two parts are already we calculate, then you need to multiply those two answers. Then after you can calculate the final answer as 1 divided by 10. Okay. Definitely you need to clearly it should be identified. Okay, what the applied here concept, what's the concept apply here. Okay. Reason is you need to clearly identify what is the event. Sometime some event will be depend. Sometime both two events will be uh, not depend, independent. Okay. Then both two concepts are very different. Okay. Then you need to calculate this example 5. Example 5 is dependent event. Okay. Dependent mean uh, when we get the first ball or when we when we get the first black ball, after that you need to get second ball, you are going to get the second ball, but first ball we are not going to replace, then second attempt depend with first attempt. No, that's the reason. Understood? Yeah, good. Definitely you need to identify what's the event. Okay, dependent or independent. Did you all write down this example 5? If you need more time, I can give. Okay. Do you need more time? Did you all write down this example up to example 5? Ah, okay. Okay, no. Okay, we can move. Okay. Here also, this concept is very important. Mutually exclusive event. Mutually exclusive events. What's the we can discuss what's the mutually exclusive event. What's the meaning of mutually exclusive event? Two or more events are called mutually exclusive if the occurrence of any one of them exclude the occurrence of others. Occurrence of the others. Thus, if E1 and E2 are mutually exclusive event, then probability of E1 and E2 events happening at a simultaneous is a mean same time. E1 and E2 events happen on same time. What the answer is 0. Okay, I think you can understand Likewise, okay. Mutually exclusive mean likewise. Those two events are, this one is E1, E1. This one is E2. Both two ends are mutually exclusive. Okay. That's the reason probability of E1 and E2 happen in same time is zero. Understood? Mutually exclusive is meaning of mutually exclusive this one. Simply, okay. Understood? Mutually exclusive event. What the meaning of mutually exclusive? Mutually exclusive. Understood? Yeah. Okay, good. Okay, we can move. If E1 and E2 are mutually exclusive event, then probability of E2 and E1 happening in same time is zero. If E1 plus E2 denote the event that either E1 or E2 or both occurs. This one is very important. Either E1 or E2 or both occurs. Then you can represent like that. Likewise. Okay. Probability of E1 plus E2 mean either E1 or E2 or both occurs. Uh, equal probability of E1 plus probability of E2 minus probability of E1 and E2 events are happening or occurred in same time. Understood? In set theory, we use this plus symbol. We can replace this plus symbol with this symbol, I think. No? Understood? I think you all have some experience with this set theory. In set theory, we use this plus symbol instead of this plus symbol, this symbol. No, this one. Do you all have experience with set theory? Set theory? Yeah. Ah, good. Okay. Then, in this concept, we discuss with mutually exclusive event. No? Then, mutually exclusive means this. Then this answer is zero. Then find what the final answer. We can calculate probability of E1 plus E2 is probability of E1 plus probability of E2. Only probability of E1 plus E2. Reason is this one, this expression is zero. This part is zero. Okay. Reason is this E1 and E2 events are mutually exclusive. Okay, mutually exclusive. As an extensions of this, if E1, E2, blah blah E1 are n mutually exclusive events, mean there are n events. Those n events are mutually exclusive. Then events having respective probability of occurrence P1, P2, blah blah, Pn, then the probability of occurrence of either E1 or E2 or En is how to calculate. You can calculate the probability of those n events are happening. You can you can add those P1, P2, and up to Pn as a separate event, separate probability. No, reason is those n events are mutually exclusive. That is very simple. Okay, each and every events are mutually exclusive. Then we can get the we can get final answer by using additions of each and every probabilities. Okay. Okay, I think you all understand. This is a very simple expression. This is a very small concept. This one also you can write down. After write down, you can face the some small question. Okay. Firstly, you can write down these expressions and this concept. Okay. Not need to write down those entire slide. Okay. Sometimes this slide will be share your manner. Then after you can follow those things uh, in simply now you can write down. This one is very important. This part, this one, then after this one. Okay, now okay. Here available another example. If E1 is the event, drawing an ace from the deck of cards, and E2 is the event drawing a king. Then what's the probability of E1? What's the event of E1 drawing an ace from a deck of cards? Mean what's the deck? Now what's the ace? What's the symbol? This one. Okay. Okay. What's the probability of E1 event is 4 divided by 52. Okay, then after you can simplify this answer as a 1 divided by 30. And what's the probability of E2? What's the event E2? E2 event is drawing a king. Drawing a king. Drawing how many cards are available in card pack? Only 4 cards. Then here also answer is 4 divided by 52 mean 1 divided by 30. Okay. The probability of drawing either an ace or a king is a single draw is you can calculate by using this formula. Okay, this formula. What's the reason for use this formula? Those two events are mutually exclusive. Mutually exclusive. Then you can add 1 divided by 13 and 1 divided by 13. Then you can get the final answer as 2 divided by 30. Okay. 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 Another concept here is available. Probability distribution. Probability distribution. Uh, you can uh, read this concept. This probability distribution is explained for discrete values. Okay, discrete value. If a variable x can assume a discrete set of values x1, x2 up to xk with respective probabilities p1, p2, and pk, where p1 plus p2 plus and p up to pk is 1. You know some what's the total number of probability, or what's the total number of ways some events happening is 1. Okay, some event, if some event is failure, uh, other part will be remaining part will be success likewise. Okay, then entire part total probability of some event is happening is 1. Okay, that the reason here mentioned p1 plus p2 plus and up to pk is 1. Okay, we say that discrete probability distribution of for x has been defined. The function px, we can mention probability for x, discrete value for x, which has the respective value p1, p2 up to pk for x equal x1. In commonly, we can denote this event as a discrete value as a x, but x this x variable, this discrete variable, we need to replace with x1, x2 up to xk, is called the probability function or frequency function of x. Okay, this formula or this function we can represent as probability function, otherwise frequency function for x. In here mention x, frequency function for x. Okay, because x can assume certain values with given probability. It is often called discrete random variable. Discrete random variable. A random variable is also known as a chance variable, chance variable or stochastic variable. Stochastic variable. Okay, those words are not important. You need to identify, you need to understand, you need to understand what's the concept of in here mentioned. Okay, probability, what's the probability distribution? Okay, this probability distribution explained for discrete value. Okay, here available some example. Here available some example. Okay. Example 8, let a pair of fair dice be tossed and let x denote the sum of the points obtained. Sum of the point obtained. Then the probability distribution is as shown in table 6.1. This is a table. For example, the probability of getting sum 5 is 4 divided by 36. In here mentioned sum 5. Okay. Probability of getting sum 5 is 4 divided by 36. After simplify, 1 divided by 9. Thus, then in 900 tosses of the dice, we would expect 100 tosses to give the sum 5. That's the meaning of this expression. Probability of getting sum 5 is this answer. Meaning is 900 tosses of the dice. We would expected 100 tosses to give the sum 5. Okay. Note that this is analogous to a relative frequency distribution with probabilities replace the relative frequencies. Thus, we can think of probability distribution as theoretical or ideal limiting. Okay, here mentioned some tables is available. Uh, this x is a variable. Okay, x is a variable. X that this variable x can be 2, 3, 5. Likewise, those events will be happen. What the probability of those events are happening in this row mentioned? What the probability those events are happening? But when we consider in total probability of those events, should be 1. Okay, it should be 1. Now here also available some example. This type of questions also will be available on your I think this is a past paper question. Okay, uh, you also try those questions. I can explain what the how to solve this question. Okay, uh, the discrete random variable x. This is the discrete random variable x. It's a random variable. Okay, this variable can be replaced with some different values. Okay, probability of x equal x mean likewise. This x variable can be 2, can be 3, can be 4, likewise any other values. Okay, this is a random variable, has a probability function. This is the way we are going to express probability function. Okay, this is the way we are going to express probability function. What is the function? This x can be kx. K is a constant value. Constant value. Okay. This x can be, this k can be constant. This probability function we need to consider with kx. When we are, which time we are going to consider this kx, random variable we need to replace with 2, 4, and 6. Random variable 2, 4, and 6. When we consider in random variable as 2, 4, and 6, then probability function is kx. Okay. Random variable, when we consider in random variable is 8, probability function is k multiplied with x minus 2. Okay. Otherwise, probability function is 0. It means for other answers or for other values, this probability function is not responding. Okay, or this probability function is not affected with other values. Okay, then you already know in what the total number of probability, what the total number of probability is 1. Then you need, in this question, you need to calculate, you need to find the value of k. I already mentioned this k is 1. Okay, is a constant value. Then you need to calculate what the answer for this k. Then you need to replace those 2, 4, and 6 with this random variable. Then This is the answer for first part. Probability function for x equal total number of probability is 1. Then after, how what are the ways this function, this probability function is happen? You can replace likewise. K multiplied with 2 plus k multiplied by with 4 plus k multiplied by with 6. Why? In this probability function mention, what is the answer for probability function by when we consider in 2, 4, and 6. Then you can then after you need to add k multiplied by with 8 minus 2. What's the reason for getting 8 minus 2? This also this part also affected for probability function. Okay. This part also affected for probability function. Otherwise, those answers are those values are not going to consider with probability function. In this probability function mention, those things we need to calculate for the k. Then after plus with those answers and plus 0. Then after calculate the k. What the k is? 1 divided by 18. Understood how to calculate the k? This is the way how to represent probability function. Okay, probability function. This type of represented this type of expressions also will be available on your question paper. Okay, then if you understood this concept, then in final exam you can face very easily your question. Okay, understood. Others, only 1, 2 persons are responding me. Others, okay. Okay, na? Then second question is find the probability when x less than or equal 6. X less than or equal 6. As well as you need to calculate the probability when random variable value less than 10. Okay, those two parts you need to calculate. How to calculate? Firstly, we can consider random variable less than or equal 6 mean this part, no? This part. Now we know what is the value of k. Already we calculate, we find. Then you can replace this k with 1 divided by 18. Then after multiply by with those three random variable. Reason is you not need to consider this part. Reason is already mentioned in this question. Random variable should be less than or equal 6. Okay, should be less than or equal 6. Okay, only three parts should be considered. Then after you can get the final answer. Okay, second part is x or random variable less than 10. Less than 10 mean what the meaning of less than 10? You can consider 9, you can consider 8, 7, those things, no? But you need, you cannot consider other values. Mean here only mention 8, 2, 4, and 6, no? 9, 7, those 5, those values are not mentioned. Or if someone is or someone already mentioned this is a probability function, you need to you definitely consider only that probability function. Okay, you not need to assign, you need not need to get other values. Then you can calculate. Actually, this one is not need to calculate. Reason is x less than 10 mean those all values are you need to consider. Mean this is a total number of probability. No, this is when we considering random variable less than 10 mean you are going to consider entire probability function. What total number of probabilities happening with this probability function. Okay. In here, then you need, otherwise you can calculate. Okay. K multiply by with those 2, 4, 6, and then after K multiply by with x minus 2 mean 6. No, those answers you and those steps you can follow. Actually, this one is not need to get effort to calculate final answer. Reason is in clearly mentioned in this question what the random variable it should be less than 10. It should be less than 10. Then those less than 10 mean those factors, those values should be you need to consider. Those values means 2, 4, 6, and 8 mean total number of possibilities. Now, then what the final answer? It should definitely it should be 1. Okay, understood. Understood or not? Home 81, understood or not? 27, no, no. Okay, I can explain again. Home 81, understood or not? Yeah, I can explain. Okay, okay, okay. Total part I can explain. Okay, here this is the way how to represent probability function. Okay, this is the way how to represent probability function. Those things will be replaced with if you are in your final exam paper or any other model papers. Those parts are not should be same. Okay, this k value replaced with another constant value. This x can be replaced with another variable like that. Those things can be replaced. Those things can be changed, but uh, commonly, this is the way how to represent probability function. Okay, in here, probability of x is a random variable. That random variable you can replace with this x value. This x value can be given with this question. Okay. In here also mention what is the value for x. When x value can be 2, 4, and 6, when we the probability function, when the probability function kx, it can be replaced with 8. What's the probability? What's the probability? K multiplied with x minus 2. Okay. Otherwise, mean for random variable is when random variable replaced with 5, uh, 1, 3, 10, 9, those things. When we consider in likewise, it it not going to respond for probabilities. It not affected for probability. I think that part understood. Okay. Then you need to calculate firstly What's the answer for K values? What is the answer for K? Okay. You know, in first part, in first thing, here I mentioned definitely in probability distribution function, what's the total number of probabilities? What the number is? What the value for total probabilities is one. Okay, no, you already know. This is a small concept. Okay, in here also mention uh, same part, same concept. You need to consider total number of probability is one. Likewise, then you need to find what are the ways that probability happen that function can affect it. Okay, in here, so in here mention what's the probability of random. What is the probability for this random variable x? You need to replace this random variable with this simple x. Simple x already mentioned in this question. Okay, total probability is 1. How to calculate? How to get this 1? By using your factors. You can get those values by using this probability function k multiplied by with 2. Why k multiplied by with 2? In this probability function already mentioned. K multiplied by with 2 plus k multiplied by with 4, k multiplied by with 6. Then after, what is the next second factor? This one, k multiplied by with x minus 2. But in when we consider in this factor, what's the k value? K value we said you cannot consider any other values. Okay, when we consider it, when random variable replaced with 8, it should be it affected with likewise. It's affected with this value. Okay, it affected with this value k multiplied by with x minus 2. Other value for other values it uh, for other values probability function is not going to respond. Okay, then what the total number is 1. What the total number of probabilities is 1. Then you can calculate in here 2k, 4k, 6k mean 12k plus in here 6 mean 6k mean 18k. 18k in this side 1 equal 18k. Then after you can calculate k as 1 divided by 18. I think this part is okay. Okay. Then after, this is a second question. In this second question, there are two questions. There are two questions. First thing is, what is the probability when random variable less than or equal 6? What's the probability when random variable less than or equal 6? Less than or equal 6 mean what the random variable values mean? 6, 5, 4, 3, 2, 1, 0, -1. Those things no. But in probability function already mentioned, already have been mentioned, what are the values you can consider for calculating this probability function? Only you can consider those things, no? Only you can consider those things, those values. In this question mentioned random variable or random variable less than, definitely it should be less than 6, less than or equal 6. Then what are the values you can consider? You can you consider 6? Can you consider 6? Reply me. Can you consider value 6? Yes, we can consider. Can we consider value 5? Can we consider value 5? No. What? No, yes, good. Reason is in this probability function, you are already not mentioned, you can consider 5. Only 2, 4, and 2, 4, 6, and 8. But 8 is not less than or equal 6, then only you can consider 2, 4, and 6. Okay, now how to calculate probability? When we consider in probability less than or equal 6, what is the affected function? What is the affected probability? On what is the affected value you are going to consider? You need to consider kx, k multiplied by with x minus 2, this one or this one or those two parts in this incident. Which part you need to consider? Only kx. Yes, good. Only kx. Reason is in this question already mentioned x less than or equal 6. Then definitely you need to consider only kx. Now you can calculate the probability kx uh, by using kx. In here mentioned kx. You already we know k no. Already we calculated what is the value for k. Then after k multiplied by with 2, k multiplied by with 4, and k multiplied by with 6. Then after you can add those three parts forget the final answer. Understood? Yeah, good. Now okay, no? Uh, this part also same. This part also same. You can calculate probability when random variable less than 10. Random variable less than 10 mean you can get the value as 9, 8, 7, those things. But in probability function already mentioned what are the values you need to consider. X is 8 and otherwise x is 2, 4, and 6. Then when we consider in x is 8, then you need to consider this part. Otherwise, you need to consider kx part. Then you can calculate those things. Okay. It is the same. It's the same way you need to calculate. Okay. Okay. I think you all understood that concept. Uh, we can move only half an hour. Okay, we can move. Okay. This is the last part. I think. Yeah. Yeah. Mathematical expectation. This one also very small concept. Those things are not very important. Okay, this is a small concept. If P is the probability that a person will receive a sum of money S, the mathematical expectation or simply the expectation is defined as PS. This is a very small part. Okay, in here available some small example. After sharing this document, you can write down those things. This part is very small, okay, and very easy. And this is the way how to calculate expectation of some particular variable. How to calculate expectations of uh, particular x variable. You need to consider what's the probability of that event happening. What's the probability that event happening? Likewise, you need to add those events with multiply by with that event, that probability. Then after, you can calculate what is the expectation for particular random variable by using summations of px. Okay, this is very small. Okay, okay. Uh, this one is very important. Combinatorial analysis mean under this concept we are going to explain, we are going to discuss combinations and permutations. I think you all are studied in A11 second, A11 period. What's the combinations and permutations? Okay, I think, can you, anyone, any volunteer, can you explain what is the difference between combination and permutations? Combinations and permutations. Okay, how I can explain. First thing is permutation. Permutation. Permutation mean number of arrangement. Number of arrangement. In this example, mention the number of permutations of the letter A and B and C taken two at a time. Mean by using these three letters, some person is going to select two characters. Okay, two at A, letters A, B, and C taken two at a time. Means how to represent this part, these expressions by using uh, statistical theory. Three in here mention P mean permutations. Permutations of two. Okay. Number of permutations from these three letters, then they are going to select two, two letters, only two letters. Then you need to calculate what is the probability or what is, yeah, what is the number of events by using permutations. You can calculate by using permutations, or actually this is we can simply say as a arrangement. What are the different arrangement? Arrangement, number of arrangement we can represent likewise. We can represent by using this expression. Okay. Okay. These expressions we can express likewise. Uh, Factorial value for 3. Then after you need to divide by, sorry, in here 2, in here 2, 3 minus 2. Okay, what is the answer? How to calculate factorial values? How to calculate factorial value for particular number? In here, you need to write down likewise 3 multiply 2 multiply 1. Then after, What's the answer for 3 minus 2 is 1. 1 factorial value for 1. What's the answer? Factorial for value for 1 is 1. Then after final answer is 6. Then what are the arrangement? Number of arrangement is 6. Okay. In here also mention what are the arrangement. You can arrange those two letters in. We can assume between this among this A, B, and C, where we select only two characters. That arrangement, that selection, actually that arrangement can be A, B. Okay, A, B. Otherwise, that arrangement can be B, A. This one also possible. Then after, we can consider A and C, as well as we can arrange those two letters as C and A. This is also another different arrangement. Then after, we can consider B, C, B, C, as well as C, B. Those 6 possibilities can be happen. Okay. Now, this is how to calculate permutation for some particular event, some particular occurrence. Okay. Okay. No. Uh, yeah. This is the final part. Is combination. Combination. Combination means what different selections. What are the number of different selections? Thing in particular class there are 3 students. Then teacher going to select only 2 students from this from that 3 students. Likewise, those concept we can identify it as a combinations or selections. Okay, how to represent combinations? By using we can represent combinations by using capital C. Okay, capital C. In this part not mentioned C, NCR. Okay, NCR. This is a combination for uh, this is a combination. In here also I mentioned you can write down what is the expression. A combination of n different object. N different object. Okay. Uh, when we are going to considering or when we are selecting from any particular object, this is the total part. Okay. This is the total part. N different objects taken R at the time is a selection of R out of the N objects. Simple meaning of this expression, you are going to select R objects from N objects. Okay, from different N objects. A combinations of N different objects taken R at a time is a selection of R out of the N objects with no attentions given to the order of arrangement. In these combinations, we are not going to consider, consider arrangement. What are the order of arrangement? Order is not going to consider in these combinations. Okay. Uh, in the permutation part, we need to consider arrangement. We need to consider order. Order also very important. But in this combinational part, we are not going to consider combination. We are not going to consider order of the arrangement. Okay. Uh, someone write AC, CA in combinational part, those two expressions is same. Okay, mean in combinational part, we are not going to consider order of the arrangement. Okay, order of the arrangement. How to represent combinational theory? NCR. Then after you can calculate NCR by using this expression. Okay, factorial value for n divided by factorial value for r multiply by with n minus factorial value for n minus r. Okay, in here also mention some example. Example 13, the number of combination of the letters A, B, and C taken two at a time. Taken two at a time. What are the total events? What is the number of total events? A, B, and C. What are the total objects are available here? A, B, and C is 3. Now we are going to take in only two characters at a time. Okay, now then you can represent this expression as uh, a 3C2. Okay, now NCR likewise you can represent 3CR mean R mean 2 equal 3 multiplied by 2 mean in here uh, you can calculate you can multiply by with 1 also. This one is not affected. No, this is a factorial value for 3. This is a factorial value for 2. This part, uh, this value is 1. Factorial value for 1 that are not mentioned in here. This is a definitely 1. Then final answer is 3. Okay, no. Those three concepts are very different. Permutation is another concept. Combination is another different concept. Definitely, you need to identify what are those two concepts, permutation and combinations. When we are going to solve some permutation related problem, then definitely you need to consider order of the arrangement. Okay, no, order of the arrangement in this permutation part, definitely you need to consider what are order of the arrangement. But in combinational part, we are not going to consider arrangement, order of the arrangement. Okay, order of the arrangement, we are not going to consider with this combinational part. Okay, and here mention how to calculate combinational theory by using Excel. This is the way how to calculate. You can get the experience with Excel also. This one is not affected with this subject. Okay, those things are definitely you need to follow because those things are very important. Okay, okay, okay. Uh, if you understood those things up to now you can get experience with those questions. I think there are two questions. Yeah, only two questions are available. After solve those questions, firstly you can solve first question. You can share your answer with direct message. Okay. Then after I can respond your answer is correct or not. Firstly, try those five part A, B, C, and D and E. From 29 here. Yeah, good. Okay. Yeah, com 41. Okay. Those things are okay now. Up to now, those concepts are finished. Now you can get get experience, or you can solve those questions, and you can think, and you can sharp your mind with those questions, earlier studied things. Okay. Up to now, those concepts are finished. Okay. I will answer from you. Okay, one by one. Then you need to solve those questions. Okay. Com 30. Are you okay with those concepts? Com 30. Yeah, good. Com 41. Okay, no. Com 49. Are you here? Yeah, good. Com 42. 52. What's the answer for part A? Okay. Com 70. Did you finish part B? Com 70. No, okay. You can continue. Okay. Okay, com 33. Share all the answers. Okay, good. Okay. This is the answer for first part. Okay. If anyone trouble with first part, now you can get correct answer in this part. Okay. By using this part. If you can get the snapshot or screen record, I think it will be better for your final exam. This type of questions also will be available. Okay. Yeah. Com 76. Okay, good. Okay, no? This is the second question. I think time is finished. If you can get a snapshot after, or if you can write down this question, after then you can complete after that. A ball is drawn at random from box contain six red, four white, and five blues. Determine the probability that ball drawn red, white, blue, not red. This question is also very easy. Okay. Okay, no. Okay. I think you all understood those concept I already explained. If anyone trouble with any concept, I can share this document. After that, you can follow this document. Uh, After that, you can follow this document. Then after, you can uh, solve those two equations, and if you need more questions, ask me. Okay. Okay. All are okay with this concept, those concepts today we are explain from 27. Okay. Okay. 40. Okay. 1. Okay. Others. Okay. No. Okay, good. Okay. Okay, then okay, we can finish now. I wish for you all for your new year 2026, and we can meet on your physical lecture uh, in near future. Okay. 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 Thank you.